welcome to a new video here on the Ludwig Fusel channel. Now you're going to see that this video again is done in a bit of a different style because I'm currently on holidays and I've taken a few weeks actually where I've not thought about anything with YouTube. I just tried to relax a bit, and I also went on holidays and relaxed from my job, and now I'm back with fresh new ideas that I worked on and also want to do videos on. And there will be a new video dedicated to just explaining what will change on the channel and what will go on. Sometimes it's good to stop and reflect, but this is not the topic about today's video. The topic about today's video is the update in my C++ template repository called MoxPP that you can find on github.com/moxybyte/moxpp. MoxPP, if you can recall, is a C++ template repository that integrates Premic 5 and Conan 2 on Windows and Linux in a quite handy way. It's like, yeah, all automated. There are scripts that do everything. There's a template. You can just directly start without hesitating. And yeah, I have done a major update to this repository. You can see the release notes here in the GitHub release. And I have called this update the continuous integration update. So what I tried to is go a bit towards CI, so continuous integration, to make MoxPP more suited for business grade software is how I want to call it. So basically what I've added is I have added unit testing to the repository as a template so that it can get easily started with unit testing. And what I have added is a continuous integration check. Basically, I've added GitHub actions, so there are multiple actions defined now already in the template repository. If I would go to actions, you can see that we have two actions defined. We have a build action that tries to compile the code, and we have an action that runs the unit tests. And you can see already we have a few runs in here that have executed. And now for me, GitHub Actions, it was a thing that I definitely wanted to have in there, but it comes with a bit of a precaution because actions do cost money if your repository is not public. So if you are cloning this repository or this template into a private repository, you might get some minutes on your action counter. If you are private, you have a certain budget of actions. I think since I have GitHub Pro, it's actually quite a lot. So yeah, even with the not paid version of GitHub, you have a few minutes of actions, but you just want to make sure that you do not add this template, or if you want to add this template, instantiate this template, make sure to exclude the GitHub workflow folder by basically just downloading everything as a zip, modifying the folder, and then pushing it as a new repository when you don't want to have actions. However, I would encourage using the actions. And again, everything in this template repository works on Linux and Windows. So all the continuous integration also currently works on Windows and Linux. If I would take a look at this, you can see that there was the build code and run unit code on Linux, so build Linux and test Linux, and then the same build Windows and test Windows for the Windows operating system. You can see Windows takes quite a considerable amount more of time. But that's just because it's Windows. Now today I just want to show you how I intend to use this library, how a software development workflow would look like that. I have extensive videos where I was already explaining how this repository works. Today I just want to give you a quick update on this and show you what the suggested workflow is by writing a class, writing a unit test for the class, and using the class in an application. Okay, so how can we get started? So the first thing that I want to do is I want to click on use this template and create a new repository, and we're going to call this one MoxPP. Let's call it MoxPP underscore tutorial. I'm not sure. I think I did or probably already did a tutorial on MoxPP. No? MoxPP MoxPP minus tutorial is already existing. Okay, so then we do version 1.1. Can we do it? Yeah, let's do it like that so that we have a bit of consistency here. So the template is the Moxybyte MoxPP. I'm creating this under my personal account, and we're going to call this one simple tutorial for the new MoxPP version. Okay, that's what I want to do. This is going to be public, of course, because you need to be able to see it. And now I'm going to create the repository here by clicking on create repository. And yeah, now it's generating the code. You can just hit refresh. Most of the time it will be already there. And you can actually see that this is really cool. The action did not start out of the box. So if you are cloning it the first time, you do not run into the problem that an action may run. It might even, okay, no, the actions run. Okay, I'm sorry. They do actually run. Well, why did it not show me that? Ah, okay, now it shows me. Okay, so it was just pending, but this is what I mean. If you are cloning that, it will start these changes on your repositories. It will start these on your account. So if you are using this repository without precautions and you have a full budget and you have already used the full resources that you get with GitHub free, then you might run into a way that you need to pay. But I think you can also tell GitHub to not pay you by disabling actions or something. But in general, now the template got a bit more dangerous by adding actions for your wallet, but it cannot be too dangerous actually. Okay, so what we can do now is after we created that, we can clone that. So I'm going to copy that URL. I'm going to open the folder here, and then I'm opening up my command line, and I'm doing a git clone quickly. Okay, this is going to be hard. Okay, no, right click works because I'm here on my iPad, RDP into my virtual machine over VPN. This is why you get this bar up here and why the sound might be a bit odd, or the ratio and things. Yeah, now we have it, the MoxPP tutorial V1.1. I'm going to open this with Visual Studio Code so that we can work on that. And I want to show you the changes that I made. So first of all, you know that there is, if you watch the previous videos, there's a big checklist here. A checklist that you should go through in order to understand how everything works. Now, I'm not going to go into the details because also there is a video that's showcasing that. I'm more or less just walking you through how I do it. Normally, it's doing this a bit different. It's walking you through the project a bit more intense. I know what I'm doing, so I'm going to start a bit faster. Now, the first thing that I'm going to do is I'm going to change a few things in the Lua file, or do we actually change it? No, actually we don't. For the sake of this tutorial, we don't need to change anything. Let's just hop directly in the project. Of course, it would be nice if we change things, but for now, I do just want to quickly initialize it by opening up a CMD. This is important that it's a CMD. If it's not a CMD, you need to do it a bit different, but I would just recommend always going for the default CMD and not the PowerShell. You can also do it by taking the drop down here and then selecting the command prompt, which by me is the default one, but I think if you install Visual Studio Code, it defaults you to the PowerShell. Which you should be able to do like view command palette and then default terminal, or how is it called? Terminal. Default, yeah, here, terminal, select default profile. If you're doing that, you can select which is the default one. I want to have the command prompt, and then it will not annoy you with the PowerShell again. So if you run Mox in it, it will initialize the repository and create a Visual Studio solution. If you do it on Linux, it will generate makefiles, so it's automated, it works out of the box. Now, you can see that the dependencies have changed a bit if you are comparing that to the previous versions of MoxPP. Now, SPDlog was already in there, and FMT because of SPDlog was also in there. What we are now getting out of the box is gtest for the unit tests. Now, in the end, we are not hard coding it to gtest here in the MoxPP template repository. So if you don't want to use gtest, any other testing library is fine. You just need to modify the Conan file and just include a different testing library with Conan, or even include your own one. I don't know, you can write just a normal C++ application. The only thing it really needs to do is the final executable must be named unit test.exe in order for it to work, but everything else it doesn't really care about. And the only thing, of course, that changes in the test folder is, of course, the test code, because this is test code. And of course, if you're using a different library, you need to adjust the test main and the test suite so that they will not like depend on any Google test related things. If you don't change it away from Google test, everything is fine. If you don't want to have unit tests at all, you can just delete the test folder and go into the mox.lua file. And in the mox.lua file, you would set the CMOX unit test source to nil. And if you set this to nil, like nil is the null or null pointer in Lua, if you would set this to nil, which of course I don't want to, no, come on. Siri wants me. Yeah, but if you changing the folder name here, you can rename the folder, and if you put it to nil, it will basically just disable unit testing all along. But that's what we want, of course, now. Now, if you're running that, you get a solution called moxpp.sln. You can open this up like that, or just double-click the file in the Explorer. And yeah, now as you can see, you have two projects in here. You have the unit test project and the Hello World project, which is the out-of-the-box project defined by MoxPP. Now, if you take a look at the Hello World one, it should just print Hello World as an SPD log warning. So if we are starting the debugger, you should just get a CMD window that says Hello World. And there we go, we get Hello World. Now, what you have as well is the unit test, of course. It's also integrated in Visual Studio. So if you want to run the unit test, you can right-click it and say debug, start without debugging. And if you do that, it will compile that and run it from within Visual Studio. There's also a different way of running that, but currently you can see that all the tests succeed. We could just make this one fail by basically telling that 1 plus 1 is 3. If we tell the unit test 1 plus 1 is 3, of course the unit test will fail. So if I go to debug, start without debugging, we'll recompile the test suite, and then it will say that it failed because it is 3, but it is 2, but it is expecting 3. Now if you want to test from within the console, you can just go for mox test to run the unit test, or to compile and run the unit test. You're going to see that it's regenerating the project. It is compiling the project in the command line with MS Build. And at some point, you're going to see that it generated the code, and then it will run the unit tests, and then you can see that it failed now. And if I would go, I think, what is it? Error level, I think. If you would echo the error level, you can see that the error level is 1, which means that we have an error. If we revert that, we can also revert it using Git. If we revert that to 2 and run it again, not the echo, the mox test, it will of course regenerate everything, because that command is basically made to just unit test it on a project. It's just like dumbly doing everything that it needs to get a unit test up and running, even through things might not have changed. Okay, but now you can see that it succeeded. And if I now run the echo error level, you get an error level of 0. So you can see even through you're using the mox scripts, it is still propagating the error level, and this is done with return code magic and passing a return code through 15 Python scripts and things like that. But yeah, you do not really need to care about how I pass the error codes. Now, what I want to show is I want to show how to properly use this library or this template repository, how it's meant to be used with the unit tests. For that, I'm going to quickly close out of Visual Studio, and I'm going to change a few things. Now, first of all, let me delete everything that we have in here. Not everything, I want to still keep the build. Let's delete these. Let's move them to the recycle bin. And let's get started with an empty source folder. Now what I want to have is I want to have a new folder called lib. This is going to be a library. And then I want to have a new folder in here called app, which is going to be our executable. I'm going to take the build.lua file and move it to the app folder. I'm going to copy that and paste it to the lib folder. So now we have two builds, one for app and one for lib. To make this work, we need to go to mox.lua and change the layout to not a single project, to a flat project, which basically means that we have a flat folder hierarchy, so app and lib. That's more or less everything that it does. And then what we need to do is we need to adjust these build scripts. Now, first of all, you can see that the default one is called Hello World. Now, I just want to call this one app now, the application. I don't care about any of these comments. I most of the time delete them. They are just in here so that you can understand how this file works. But I most of the time go and delete these comments, you can always take a look at the reference in the root template repository, how it works. Now you can see that app from the application type is a console application. That's fine. So we can leave this like that. Then we can remove that because the application is not required for unit testing. Only the library will be unit tested. That's the main idea. You have components in your library that get unit tested and then used together in the app. If you have any business logic, they should be in the app and should basically be tested with the library, or the business logic should be in the library, in the business logic library, and should be unit tested, and the app should more or less just yeah, for example, based on a configuration file, composite everything together, or just hand over the call to a library. I like to do these kind of bootstrap applications that just call library functions, and even if it's just a invoke application, so that all the code that you have in the application is also a library. So if you want to release an SDK or something, or want to make your application be able to be plugins written for it, you can just simply ship your library and some API headers that are exposed, and you have an SDK out of the box, which is good to have. Okay, so now what we of course need in our app is our library. So I'm going to link to the library. We don't need any of these fancy depends on. So that's basically how an app would look like. It's a project called app. It uses CPP20. It's a console application. It will link to the library called lib. Now, how do we configure lib? Of course, first we need to start by naming the project. In this case, it's no longer called Hello World. It's called lib because it's our library. Again, it's a C++ application, CPP20, but now we need to change something. Now this is a library, so instead of Mox console, it's going to be a Mox static lib, which makes it a static library. And now we have one thing that we need to tweak because of the unit testing. Unit testing have automatic dependency resolving. So if you use any library in your unit tests, you just need to include this line, Mox test requirement. If you have this line in here, it will automatically register that to a list of libraries required for the unit tests. And when the unit test is generated, it will automatically link against the library. And that's it. That's everything that I want. Everything configured like that. And now the only thing left to do is refresh the solution. How can we refresh the solution? Normally you would do this with Mox init. However, Mox init also invokes Conan. However, I don't want to invoke Conan because it didn't change anything. In this case, it really doesn't matter because we do not have a lot of dependencies, and deploying the Conan dependencies is fast. However, if you have a big library, like for example Boost inside, then deploying the Conan dependency is painfully slow, and therefore I added a skip Conan option. So Mox init skip Conan will basically just invoke premake. You see, no Conan code, just the premake solution is refreshed. And then you can go for moxpp.sln and open it back up in Visual Studio, and we can start writing our code. And I can show you how I mean to use it. Now, what we now have is the app, the library, and the unit test. The app does no longer have a main function. That's not so cool. So let's add this first. So let's add this one. Okay, let's call it a CVP file. I want to have the compact view. Yeah, there we go. We have the CPP file, main.cpp. Okay, so what are we going to do in main? Int main. I think we can just do it like that. I don't want to have anything fancy inside. And the only thing that I want to do here is, let's include iOS stream. And let's include regex. I don't know. Do I want to really use regex? I think yes, because regex are powerful. I've used quite a lot of regex these days because the regex is really powerful. So what I want to do is I want to have an STT string, call it line. And let's include string as well. String like this. That's actually, let's put it here. Okay, so let's create a line here and say std get line, and we get it from std cin, and we're going to push it to line. That's what I want to do. I want to get a line from the standard input, and just to reflect what's going on is I want to quickly std cout that line and terminate the application just to see that it works, right? If I go now to compile, no, it will fail actually because the library cannot link against the library because the library is empty. Let me quickly make the library generate some file by adding a dummy output here. Now, this is just some, not existing. This is just some quirks from the Microsoft compiler. If you have no C++ file, it will not generate a library, but if you have a dummy file, even if it's just an empty CPP file, then it will work most of the time. No, I don't want to have that one. And if I now go to start, it will compile the library, it will generate an empty library, and then you can open the app, and I can now say hello, and you can see that I get back hello. And that's basically more or less what I want. Now I want to have this one in the body, so let's call this, let's add a boolean, bool keep running equals true, and then basically while keep running, what we're going to do is we're going to get the line here. We don't want to see out the line, but what I want to see out before we get the line is I want to see out something that indicates that you need to enter a line. So I want to have like this sign here so that you kind of like have a console-like feeling, so that you need to enter something, like a cursor that tells you to enter something. Okay, so what I want to do here is I want to check if the line is equal to exit. So as soon as the user types exit, what I want to do is I want to say keep running equals false. And then we break out of the loop. That's how I want to do it. Okay, so if we run the code, we should be able to enter quite something in the command line. So if I enter something, press enter, okay, I get another prompt, I enter something, okay. And as soon as I write exit, the application exits. Okay, so far so good. Now we have built it ourselves a very, very easy command line that just enters some user code. And what I want to do now is I want to write a accumulator inside of the library. So what I want to have is I want to have my acc, not q, acc, for accumulator, acc.h. And this accumulator shall do some mass. So it's going to be the class acc for accumulator. Just very simple. We're not going to make things too fancy here. Just a plain old class acc for public section and a private section. Visual Studio still doesn't know how I like my formatting. And then what we're going to have inside the accumulator is an integer, and we're going to call this one the MAC, so it's the actual counter, and the accumulator starts at 0. And then what I want to have is I want to have a few simple functions. I want to have a void add, which is going to have an int I. I want to have a void sub for subtracting with an integer I. And I want to have, let's make this one an inline int get. I can make this const actually. And what this one shall do is it just returns the accumulator. That's my interface. That's my accumulator, how I want it. Really, really simple, not a lot of functionality behind, but enough to prove a point. Now what I can do is I can go inside of the add in here, and I'm just going to say plus equal I. I'm just writing this in the CPP file and not in the header so that we can get rid of the dummy file because I don't like dummies. So yeah. Okay, so mac minus equal the integer. Okay, now let's remove the dummy because it doesn't really prove a point that it's there, just to make the compiler happy. Now we don't need to make it happy because we have a functional library. And now what we can do is we can use the accumulator inside of the main file. So what I want to have is I want to have an include here, and I want to include the lib. So lib/acc.h, this is all, these include paths are all set up thanks to MoxPP. Now what I want to do is I want to check if my command line here follows a certain pattern. And to do this, I want to check this pattern using regex. And I do know how regex work, but I'm not always a big fan of regex. Like I know how they seem to work, but sometimes it's better to be just in here and have a bit of reference. think there's like a start of string. I just need to verify it was that one. Yeah. So, okay, so there will be the start of the string. Then we're going to have a capturing group. We're going to have a space. We're going to have a capturing group, and we're going to have a end of line. And what I want to have is and now it's going to be interesting to find the backslash on the keyboard of the iPad. Probably something that I will not be able to find. Okay, so let's insert it in here. So basically what I want to have is I want to have a digit. Any digit. That's what I want to have. Can I not copy that? But I can copy the backslash. That's cool. Let's copy the backslash and let's paste it in here. And I want to have digit star, which basically means I want to have as many digits as I want. And then in here, what I want to have is I want to have the alphanumeric characters, which I think should be also specified in here. I don't want to have any non-digits, so alpha. I don't think, I just want to have letters. But I want to have this equivalent. I like this equivalent more. So I want to have some letters in here, as many letters as I want. And that's basically my regex with two capturing groups, with capturing group 1 and 2. So what should work now is zap5. This should be captured. No, I think what I want to have is actually I want to have a plus, because currently it should just match a space. Yeah, I don't want to have a star, I want to have a plus. So 1 or more is what I want. Now, okay. And then what I also want to have is I want to have like add 6. So everything that's like seeming like a valid command should work. Okay, so that's the regex that I was building for detecting the commands. So let's actually define the regex up here. So let's do the regex. And what we're going to do is we're going to provide a raw string literal so that we are not getting fooled up by our brackets inside of here. And now we have defined our regex here. We can do it as a const. This one is not going to change. Maybe it should even be able to compile that or compile down the regex into the VM bytecode at compile time. Okay, so now we're going to have an smatch in here, and we're going to call this one cmd match. And then we're going to do a quick regex match. No, it was 8. Okay, here we go. So we're going to do go for a regex match. And I think, I'm not really sure what the SCB regex match pattern was. I think it was the line, the regex, and then followed by the match or something. CMD regex, CMD match. Was it like that? No, of course not. So let me quickly look this up. I always mix these up. I always need to take a look at the autocomplete from Visual Studio, which I don't get if I'm on an iPad. So let's quickly look at the documentation. First, last, match result and regex. So these ones should be swapped. Make it work. Yeah, okay. So these ones swapped and they work. So as soon as we are getting a regex match, I'm going to do something in here and then we're going to continue. And what I just want to have is I want to have some error feedback. So stdc out command and std handle here. And what I want to have here is I now going to have multiple things. So let's do an std string. I think we could do it making this an auto cmd equals cmd match operator. This operator here, it's easier for me to do it like that than finding the key on the keyboard, and at position 1 to get the string should be like that. This should be our command. We can make it const as well. We're not going to change it. Const auto. And then we're going to have a const integer, or let's also make it a const auto value. This is going to be equal to std atoy from cmd match. And yes, I'm copying brackets. I'm really sorry about that, but that's how it is. Dot string dot c string. This is how we can convert this to an integer, and it's safe to convert this, or okay, it's not safe because we have not specified, we have specified there can be more than what an integer could hold, but we could make this even safe by allowing like 0 to 4 or something in here. But yeah, I don't want to overdo it now. If this one fails, so shall it be. I want to check if cmd equals to add. Then I want to add, of course. And then what we can do in here is let's not make it an else if. Let's maybe grab this one from here. Make it in here. And if the cmd is a sub for subtract, what I want to do is also continue. Okay. And if it's something else, it will continue on and it will error out with unknown command. Okay, so now let's bring in the accumulator. So let's have the accu. So accu is the accumulator, now just a different name for it. And then what we can do is we can just add the value to the accumulator. Or in this case, sub the value. And then we're going to do something. We're going to say std out, or maybe let's make it different. Let's say bool cmd okay equals false. And then let's maybe remove this one out here, put it in here if cmd okay. Let's put this into the body here. Instead of continue, say cmd okay equals true here. And cmd okay equals false here. Not false, also true here. And if the cmd is okay, what I'm going to do is I'm going to echo out what the accumulator's value is. And it's going to be accu.get and std handle. Okay, so all good. We have written our small application. Let's see if it works. Okay, so we have that one. Let's just put in some garbage, unknown command, that's okay. So let's try to add 5, and the accumulator is 5, so that worked. Let's try to subtract 2. The accumulator is 3. Let's try to lel 5, which is an unknown command. Let's try to exit. Okay, there we go. And we should add a if line equals ag. Let's maybe add quickly this one and say we can break here. No, we not break here. We're going to continue. And we're going to do an stdc out quickly to also get the accumulator ag, and we're going to echo get std end line. Okay, simply like that. So if I run this now, I should be able to interact a bit more interesting with it. So I start with the accumulator of 0. I add 6. I can get the ag, it's 6. And then I can say like sub 9 from it, which makes an accumulator of -3. I can spam my console, but I still can get my accumulator with ag. And I can add 50 and be on a nice balance, and I can exit out. So as you can see, we have a working business class grade accumulator now, written in a few lines of C++ and over-engineered it with regex. Well, it's not over-engineered, regex are fine. So how do I now add unit testing? Now unit testing in this case is really important because we have a bit of a distinction. We have an accumulator, which is the core functionality, and we have a and we have an application that uses the code. Like we just have some branching in here. We could test that one by injecting a like fake CMD. So if we have a CMD interface and a virtual CMD, we could fake commands to the CMD and expect that the outputs come in a certain way. But I don't want to go too far with the unit testing here. What I want to do is I just want to go into my test suite and quickly have my ACC testing, or we can just call it ACC because it's the accumulator test. Now, basically what should work now is it should basically just work to include the accumulator here and to do a simple test with the accumulator. We could, for example, test adding, if adding works in the accumulator. Oh, come on. Adding. So let's quickly check if we can add with the accumulator. So we have an echo. We're gonna add to the echo 2. We're gonna add to the echo 4. And we're going to expect that echo.get is going to be equal to 6. That's a simple test. Okay, so now let's maybe add a few more test cases. For example, we add this test case, and we're going to go and add adding underflow. Okay, adding underflow. How can I add an underflow? I basically just add, in this case, -4, which basically should give us -2. So I just checked that I could have a underflow. I could add an underflow, it works. Okay, good. Now what we of course would want to do is we would want to copy these. And what we also want to do is subtract. Subtract, okay, that's the name of the test, subtract, and then also by subtract I want to have an underflow. So if I'm subtracting, I'm basically starting with an add of 4, and then I'm subtracting 1, and what I would suspect is I want to suspect 2, but of course I need to call sub here, and not 2, 3, okay, so we would expect 3, subtracting with an underflow, so I add 2, and then I subtract, let's say 6, so that we have a bit of different numbers, and then we have -4. Okay, so that's basically it. This is our test. And if I would run this test now, so debug, start without debugging, everything should run fine without any issues. Let's see if this is the case. Okay, there you go. All tests passed from the accumulator test suite. It's all good. Now, this is how you would ideally start. But in some cases, it might solve a problem because now maybe somebody goes into your code and says, yeah, okay, this is an accumulator, but this integer is really fitting me. I do just want to have a size t here. It should be fine to just put in a size t here and everything is fine. Yeah, okay, so he starts the application. He starts testing by adding 400, adding 500 or 5000, getting the accumulator. Everything works, nice, commits, and pushes it to the repository. Now, since you changed library code, your developer, it's going to be a problem. And this is why the unit test is here, because this is something that the unit test should now catch. We changed the accumulator implementation, and it should now have a problem. And it does not. That's cool. Yeah, it's because of two compliments. Yeah, okay. We need to fool our accumulator a bit more. Now the thing is, what's happening now is that these negative numbers, they're getting converted to size t's and then they match again, which is not really what I want. Because basically the accumulator can now no longer get... See, the problem is at 5 sub 10. It's still -5. How can it be still -5? Because it's converting the size t, C++. Okay, C++ seems to be a bit more error-proof than how I want to have it. Okay, fine, I'm going to find a different example. Somebody fools up the accumulator implementations by basically doing something like that. No, not n. mag plus I. Okay, somebody thinks, oh, the implementation is wrong. I know everything better. I'm going to fix it. Now it's working, the accumulator. And if you're doing this like that, run the unit test now with the changed accumulator, you're going to see that the unit tests will fail. And that's the main reason, all right? You can see, yeah, expected equality of these values, there's something wrong. Now you can see that the tests failed. You can actually see that There should be some tests that actually pass. Failed, failed, failed. No, actually, all of them fail because, yeah, I'm sorry, all of them need to fail because I changed it here. If I changed the other thing, I would have expected it to not fail, but yeah, in this case, my code was my idea of changing the code so that the unit test fails if the units here are not adjusted is not how it works. I would needed to have adjusted the values of how the retrieval works as well. Think maybe can I maybe let's quickly try this out. Can I make an inline auto get? Change that to a size t and then make the unit tests fail. I think I could. I should make these fail like this. I think if I change it like this, I think it should fail because I'm not converting to an integer. No. Okay. Thanks. Thanks for nothing. Underflow. Why does the underflow now? Because it's. I think it's still. Okay. Okay, I should not try anymore. I know C++ does things behind the scenes, and in int and size_d they are kind of compatible in the negative areas. I would need to have an overflow to make it fail. I would need to have like an overflow test that actually tries to explicitly overflow the integer and expects the integer to overflow, and if then the type change, it would be able to catch it because the size_t would not overflow. But if it gets converted to an integer, it might overflow. I don't know. In the end, you can see the point, right? You can just write a unit test and be good. I am not a channel to consider when it comes to unit tests. I want to use them more. This is why I integrated them in MoxPP so that unit tests come out of the box. But I'm not like a unit test guy. I really need to admit that because the thing is like I'm just a hobbyist. I'm just doing that in my free time, and my free time, especially since I'm working full time now, nearly a year now, is quite limited. The free time. I want to also make something with friends. We will have events in the company where we are being together with the nice colleagues after work. And yeah, there's a lot of stuff going on, and I did not have time for unit tests, sadly. But I hope that I can make it work better. And especially if you're going into like business class, business grade applications, unit tests are the way to go. Okay, but enough of talking. I want to show you how this now works. Now, edit implementation. So if I added an implementation here for my code and sync these changes with GitHub, you should see that everything will build and be validated in GitHub as well. Refresh the page here. You could just see the add implementation commit. And you can see here that it's now actually going in and building the code. And if I go to details, you can actually see what happens. So as you can see, currently it's installing Conan. Okay, there we go. Now it's setting up Conan. Now it's running MoxPP in it. You can see that it's fetching FMT, it's fetching SPD log, it's fetching GTest. It's actually building FMT there. It's building GTest here now. You can see it here, building CDXX object, Google mock, Google test. Okay. And I think now it should also build SPD log, calling build. Now it's building the SPD log files into the output objects. And there you go. Now it's done. No, it will do it again for debug. It will do it for debug and release. It's a bit of a pity. Yeah, it does it for both configurations, at least on the Conan side. You can also see that it's nicely running in parallel. So in parallel, Windows is also happening. There you go. Windows is also running the MoxPP in it. And also, this is just the build code, not a test, but it's all running in parallel. In this case, you can actually see that it was building the MoxPP. So linking app, linking lib, and linking unit tests, it all worked without issues. You get the check mark on Linux. On Windows, it's still a bit behind. It's still in initializing MoxPP, but we can go, no, I don't want to do it like this. We can go up and go out of build code into run unit test. And you can see that it's running here as well. You can see that the unit test on Linux also succeeded. So you can see build and run unit test. If you expand this one here, you can see that it was doing another setup here. And then you should come down to the compiler log at some point. Yeah, it might would have been better to just invoke the test manually so that you can find it easier. But if you go down here, you can actually see the output of the unit test here, running 4 tests from one test suite, run okay, run okay, run okay, run okay. So it actually already finished on Linux. If we check on Windows, it's still pending. The compile could maybe, the build test might be already done. No, the build test is also still pending. Build Windows. Ah, there you go. Now we also have the check mark on build Windows. So if you would take a look at moxpp.build, you would see the MSVC output here. Build succeeded. You should see unit test.exe has been produced, and there should be also the app.exe that has been produced. .lib. Where is it? Yeah, however, the app is also builded. It's building everything. I saw main.cpp here. There it is. App.exe has been produced. And if we go up, the unit test on Windows might have already succeeded. If I go to test on Windows, and we go to build and run unit test, we scroll down a bit. We'll see that also on Windows you have a build output, and down here the test has been executed and 4 tests has been passed. So the whole unit test was passed, which is exactly what we want to see. And if we put in any mistake, it will catch it. And it will show you the X. And you can see that there's a problem with a pull request because the pull request failed to build. And now we have this nice little green check mark with our nice little implementation of a accumulator. Yeah, but that's more or less it. Yeah, I recommend you checking out the latest version of MoxPP. It's really beneficial if you want to start business grade applications. If you want to write them in C++, you have unit testing now, you have continuous integration, you have everything that you need to run your next bigger end user project on Windows. Again, MoxPP, it's targeting the end product, an exe, not really a library. If you want to implement a library, this is the wrong template for you. Have become more or less an end application programmer when it comes to programming it, and this template has already a few times really helped me because it's easy. I can just start right out of the box. There's no hassle included in getting these things ready. Just start, finish, done. Easy. Okay, so yeah, thank you for watching. See you in the next video. Make sure to like and subscribe, and have a nice day.